Alright, hello everybody. This is your first actual learning video, so you should have your notes out, the ones that I gave you in class. If you don't have them with you, then they're posted in the materials section in your on Schoology, so you can go in through there. Okay, so we're going to see if we can cover in this video these first three learning targets here. So we're going to try to understand what a rational number understand a rational number as a point on a number line. So you'll understand kind of how to make a number line, I guess. I mean, it's pretty basic, you'll see. But they can get kind of tricky. And then we're going to extend number line diagrams to represent points on a number line. So we'll talk about that here in a little bit. And then finally, we're going to interpret statements of inequality as statements about the relative position of two numbers on a number line. So, we'll talk about what that means. But an inequality just means like greater than or less than. That's kind of what we're talking about there. So we're going to be, is this greater than this, or is this less than this, that kind of stuff. So that's what we're going to cover here. So let's go ahead and flip to the next page there. So you should have page numbers at the bottom. So you're on page 2, okay? And there's your learning targets once again. So you should always know what you're learning, okay? That should be something I should be able to ask you what the learning objectives are, what the learning targets are, and you should be able to tell me, okay? First of all, let's look at rational numbers. A rational number is a number that it's pretty much any number that you think of. So when you think of a rational number, the number 4, that is a rational number. The number 3 is a rational number. And then also fractions, 1/2, that's a rational number. 0.52 or 52 hundredths, that's a rational number. Okay, and it says any number that is an integer or fraction. So you could even get into negatives, but we're not going to worry about negatives right now. But that's all rational numbers. The reason it could be a fraction too. Now we have two fractions there, and decimals are very similar to fractions. But I want you to also know, and you probably already know this, is that the whole number 4, you could make it into a fraction by just putting a 1 over it. All whole numbers are going to be over 1, so those are all rational numbers. So we're not going to get into like numbers that aren't rational, but pretty much any number you can think of, any decimal, anything you can think of is a rational number. Integers, they are positive or negative whole numbers, so that we'll just leave that definition the way it is. It'll change a little bit next chapter, but for now it's anything like 5, that's an integer, 6 is an integer, 12 is an integer, -2, -5, so negatives also. Okay, so for instance, the number 12.1, that is not an integer. That is, however, a rational number, okay, because it has a decimal on there. So we're only talking about the actual whole number itself. That is an integer, okay? Whoop, I didn't mean to hit that. So we can kind of look at this here and see. Hopefully yours is a little less blurry than what we're looking at here on the video, but regardless, you're gonna learn how to put numbers on number lines. Here's a number line that's just very basic from 0 to 9. Okay, just kind of showing you. This right here is called a horizontal, so we're going to go ahead and write that word. Remember, if I write it, you write it. Horizontal number line. Okay, so I always like to just write it like this. Horizontal is the one that goes side to side, and right here would be a vertical number line. Okay, vertical, which goes up and down. Okay, and kind of the way I always kind of remember these is, maybe if you're an athlete, or in gym class actually, maybe you've tested your vertical jump or your vertical leap, which is how far you can jump off the ground. Well, if you jump off the ground, you jump up and down. So that's kind of maybe a way to help you remember what a vertical number line is here. As you can see on a horizontal number line, the smaller numbers are always going to be to the left, and they get bigger going to the right. Okay, which is pretty easy. Any timeline you've ever looked at for social studies, you see it getting time advancing, going to the right or going forward. Well, this is kind of the same. The numbers are getting bigger. Sorry. So if you were doing a number line with 1960, 1970, 1980, something like that, the years, well, the numbers are getting bigger as you go that way. Vertical number lines are the ones that can get a little bit more tricky. The big thing I want you to remember when you're thinking about a vertical number line is a thermometer. Now, maybe many of you may not have even look at a thermometer very often anymore because of our phones, and we have all these weather apps that just give you the temperature, so there's no point in having a thermometer. But for those of you that have seen them, the higher temperatures are always to the top. So if I had a thermometer, 90 degrees would be up here, 0 degrees would be up here, or down here, I'm sorry. So that's kind of the way it would look, something like that. And however far it went up, that's how hot it is. Well, this is the same way. The bigger numbers always get bigger going up the vertical number line, okay, and smaller going down. So think thermometer when you're thinking, if you're trying to remember which numbers go on top, the bigger or the smaller. Go ahead and go to the next page. Okay. We're going to go ahead and draw a horizontal number line. So we'll just start right here. Just do your best with your neatness with me. So draw my number line there. I'm going to draw a horizontal number line to represent the whole numbers between 5 and 12. Now I want to take special note of that word between. Okay? What you got to be real careful of is, since it says between 5 and 12, am I going to include 5 and 12 on my number line? Hopefully you're all saying no. Okay? Because we wouldn't start this. Don't write this, because this is what I'm going to erase here in a minute, but do not write what I'm about to write. We wouldn't go like this. Okay? A number line like this would start at 5 and go to 12. So it would read, draw a horizontal number line to represent the whole numbers from 5 to 12. We don't want to know whole numbers from 5 to 12. We want to know all the whole numbers between 5 and 12. So what's the first whole number after 5? Hopefully you're all saying 6. And then what's the last whole number before 12? Is going to be 11. So if we're going to represent all the whole numbers, we're just going to count by ones. Okay? You guys all know what whole numbers are. Okay, now obviously my spacing is just way off bad. Okay? Just do your best. The spacing should be accurate. Mine, I didn't do a very good job, but that's okay. Alright? Now we're going to draw a vertical number line to represent the whole numbers from 5 to 12. Do we see the difference already? Hopefully you do. Okay? Here, in this horizontal one, we were just listing the whole numbers between 5 and 12. So that would be 6, 7, 8, 9, 10, and 11. Here, we're drawing a vertical number line to represent numbers from 5 to 12. So in this case, we are going to include 5 and 12 because we're representing the whole numbers from there. So starting from there, going from there. Now, like I told you on the previous page, the hardest thing about a vertical number line is remembering whether the higher numbers go on top or at the bottom. Okay, now this is where you got to think about a temperature. What's warmer, 5 degrees or 12 degrees? Okay, both are cold, but hopefully you're saying 12 degrees. So that would mean 12 degrees would go to the top, 5 would go to the bottom. Now if we're representing all whole numbers or from there to there, then we're just going to list them out. So 6, 7, 8, 9, 10, and 11. I did a little bit better job with my spacing there. So there we go. There we practiced the word horizontal and the word vertical. Okay. And then we also really worked on the word between, and we talked about being from something to something else. Okay, so there's a big difference there. Hopefully you're saying, again, this one is just representing what's between 5 and 12. This is actually saying I want to know every whole number from 5 to 12. Okay, it probably seems very basic right now for a lot of you. You're probably sitting there going, this is basic. That's okay. Okay. Here we're going to learn what inequality symbols are. I kind of went over this, I think, in a couple of my classes today, maybe all of them. But these are called inequality symbols. So go ahead and write this, inequality symbol. And if there's ever a spot in a video where you need to go back and just rehear or listen to something over again, it might make more sense the second time. So just keep that in mind. Okay? You got to know what these symbols are, the names of them are. Okay? I like to talk about this one actually when I'm teaching it, because kind of a cool way to remember it is, when you have less than, that L right there kind of helps you remember, because if you look at that inequality symbol and that L, you could see how it's just like the stick of the L is just kind of squished down. So that's like one way to remember it, is that kind of looks like an L. That doesn't look like a G, obviously, but at least if you can remember this one, then you can know that this is greater than. The biggest thing you need to know when you're doing inequality symbols is, like when you guys were in elementary, I'm sure that your teacher drew some sort of monster, or maybe, well, if not, I'm doing it, okay, and you have your monster there. You got to keep in mind that your inequality symbol always wants to eat the larger number, no matter if the number's on, if we had that, 5 is obviously bigger than 3. You always got to remember that it's always wanting to eat the larger one. Or if it was like this, it's still wanting to eat the larger one. Okay, so that's kind of the elementary way of remembering it, I guess. But still, you should be able to read this and say, okay, that means 3 is less than 5, and 5 is greater than 3. Okay, so you do need to know those symbols. Okay? Here, if we're trying to figure out, we're trying to see 35 and 33, which one's larger? Well, you can use a number line, obviously. If we put a dot on 33 and a dot on 35, obviously the further to the right that a number is, the larger that it is, making 35 the larger of the two. So then we're going to do a greater than symbol, because, again, my monster wants to eat the larger number. Okay? Okay, here's one that maybe where we might start to struggle a little bit. 110 is less than 250. 110 is less than 250. There are probably some of you that are probably looking up here now to figure out which one's the less than symbol. If that's the case, then that should be something you need to focus on to know that, okay, I need to study that, because I don't know the difference between those two. You must know, when I give you that symbol, you must know that that's a greater than symbol. When I give you that, you must know that it is a less than symbol. Okay? So now it's pretty easy. There we go. If you know those, it's very easy. Just so you're aware, though, could I also write it like this? I hope you're all saying yes. Because either way you write it, by saying 110 is less than 250, that's the same thing as saying 250 is greater than 110. It's still trying to eat the 250. It's still the little skinny end is still facing the 110. Okay? You guys go ahead and try these two. Pause the video and try these two real quick. Okay? Hopefully you've paused it. I know that 48 is larger, so I know this is going to be a less than sign, because I know that it's trying to eat the 48. Here, 21 is larger, so I know the 21 is going to be trying, or it's going to be trying to eat the 21, so that's a greater than symbol. Okay? Go ahead and go to the next page. Okay? Here, if we are drawing a horizontal number line here, draw it here. There we go. Now this is where you got to be a really good reader, because some of these can get kind of tricky because of the reading of them can be just harder than the actual math. This isn't really math related as much as it is reading. Okay, so if we're talking about positive whole numbers less than 5, so we want to represent every number that it's trying to represent here. Okay, so first thing I'm going to do is I'm going to say, okay, I know that everything, if this was 0 right here, is there anything positive on that set of 0? Hopefully you're all saying no. It can't be. Okay, so the first whole number is number 1. 1 is the first whole number. Obviously, then we're 2. Are 1 and 2 both less than 5? Yes. Then I can go to 3. Then I can go to 4. Right? But then the final question is, should I add 5? That's kind of the question. Well, if we're only trying to list out positive whole numbers less than 5, could we put 5 on there? No, we could not, because it is not, 5 is not less than 5. 5 is equal to 5. Okay? All right, let's go ahead and do number 2 here. Okay, here we go. So whole numbers greater than 9 but less than 14. Okay, so whole numbers greater than 9 but less than 14. So we're talking about whole numbers. It's all about where you start. Where are we going to start? So it says greater than 9. So what's the first whole number that's greater than 9? Hopefully you're all thinking 10. We wouldn't put 9 on because 9 is not greater than 9. 10 is the first whole number greater than 9. Okay, but it has to be less than 14. So is 10 greater than 9? Yes. Is it less than 14? Yes. Now let's go to 11. Yes, it's greater than 9. Yes, it's less than 14. Let's go to 12. Still good. Let's go to 13. Still good. Now we come to that same dilemma we had up here. Do we add 14 on there? And the answer to that question is no, because 14 is not less than 14. We are only talking about 10, 11, 12, and 13. That's the only numbers that are greater than 9, but less than 14. Okay? Let's do number 3 right here. Put a little number 3. Okay, I know it's kind of, you might have some more space kind of off to the side over here maybe. I'm just going to do mine right here, I think. Okay? So we're talking about odd numbers. Okay, so now it's changed. It's getting a little harder. Before, it's just been whole numbers. Now we're going to start talking about odd numbers. Now, if you don't know, odd numbers are 1, 3, 5, 7, and 9, or anything that ends in those numbers. Okay, so 79 is an odd number. Okay, even numbers are 0, 2, 4, 6, 8, or again, any number that ends in those numbers. So 24 is an even number. Okay, so we're talking about odd numbers. Now there's that word again, between. So we are not going to include 1 and 10 in this because we just want to know what's in between them. Okay, whatever's in between. So what is the first odd number between 1 and 10, or the smallest one? I hope you're all saying 3. Because 2 wouldn't count because 2 is an even number. So 3 would be the first number. Notice I'm putting the smallest number at the bottom. Now I'm going to go to 5. Now I'm going to go to 7. And finally I'm going to go to 9. And no, I'm not going to go to 10. First of all, because it's an even number, but also because we're talking about numbers between 1 and 10. So only 2 to 9 is going to work. So between would mean everything from 2 to 9, right? But we're only talking about the odd numbers between there, so that's why we started with 3 and went to 9. Okay? Here we go. Let's do another one. Number 4 now. Again, try to find space. We're talking about positive odd numbers less than 15. So positive odd numbers. So and you got to know that that's a less than sign. Okay, so what's the first positive odd number smaller than 15? 13, 11, 9, 7, 5, 3, and 1. Can I go any further? No, because I would go into negative numbers if I kept going down. We only wanted the positive odds. Okay, so are we seeing how this is very much reading more than maybe even math? Okay. Okay, this is maybe where it gets a little bit more tricky here. Okay, represent. Now we're going to start putting fractions. So we're going to represent the fractions 1/4, 2/4, 3/4. Now hopefully you guys are all pretty aware that the fraction 2/4, that's obviously, if you simplify that, it is 1/2. Okay, so it did it for you here. Broke it into 3 sections, or actually 4 sections. From here to here is 1/4. From here to here is another 1/4. From here to here is another 1/4. And then from there to there's another 1/4. Okay, so you actually only have to make 3 dots. Okay, because the 1 would be this is actually 4/4. Okay, and this one is 0/4. So we got 0/4, 1/4, 2/4, 3/4, and 4/4. Okay. All right. Here we go. Now we're doing decimals. If we were doing decimals here, that you would see, okay, if we're going to represent the decimals from 0.1 all the way to 0.9, then we're going to start at 0.1 with a dot, and we're going to go all the way to 0.9 and get every tenth in between. So we're counting by tenths, or as I told you in class today, or at least some of you, that place value right there, the tenths, is your dimes. So you're just adding 1 dime every time, or 1/10 every time. Okay? By the way, whatever you're going up by on a number line, each time, whatever it is, that's called your interval. Your interval is what you go up by. So up here, my interval is just going up by 1/4 every time. Here, I'm going up by 1/10 every time. Okay? And we are going to stop right there. So just, you don't have to do this. Okay? Just come ready to go on that other stuff tomorrow. See you guys.